Hello, and welcome to Tech Connects, Dice's podcast where we dig into topics on tech hiring, recruiting, and careers that matter to you. I'm your host, Nick Kolakowski, and I'm going to talk to great guests every month about the current state of the tech careers world, including the tech job market, the hottest tech skills, what companies are doing to attract and retain technologists in a historically tight market, and much more. Data is the lifeblood of organizations everywhere, and that's why I wanted to speak to Steven Hillion, who's SVP of Data and AI at Astronomer, a company that helps other companies manage their data pipelines. It's a commercial developer of Airflow, an open source platform originally developed at Airbnb as a way for that tech giant to manage all of its data platforms and data pipelines. I wanted to speak with Steven because I was curious about his insights into so many of the data issues impacting companies today, from verifying the quality of data to fine-tuning the large language models currently powering so many of the current generation of AI products. So with that, let's jump in. As a kickoff, you're the SVP of Data and AI at Astronomer. And for the audience who doesn't know about Astronomer, like what the company does and how it fits into the broader data marketplace, I was wondering if you could give us kind of a quick breakdown on that.
Yeah, of course. Yeah. I don't know if you've heard of Airflow. It was an open source project that was started at Airbnb 6 or 7 years ago, I think. And in a nutshell, it was a platform they used to create a way to manage all of their data platforms, all of their data pipelines, the flow of data throughout the whole organization. And it soon became absolutely central to their business, but not necessarily a competitive differentiator and something that they thought they'd benefit from launching into the open source community. So that's what they did. Airflow quickly becomes pretty complicated. It's widely used. I think at this point, it's like the most popular open source project in history on Apache, something like 12 million downloads. It quickly becomes pretty unmanageable once you have lots of teams using it and you want to have lots of dependencies and lots of users and so on. So Astronomer is the commercial developer of open source Airflow, and we provide a cloud platform so that you can run all your pipelines within our central, well-managed, enterprise-grade version of Airflow. So basically, it simplifies the governance of all your data pipelines. It lowers the risk associated with that because you're running it within our enterprise-grade version. And we think also it lowers costs, really, of managing it because we take care of the infrastructure for you. You don't have to have people managing all those pipelines themselves.
So I imagine, over the past however many years, and especially in the past several quarters, you have tons of companies that have been sort of embracing, some of them for the first time, kind of embracing the value of actually, cleaning and collecting and storing and then analyzing your data, hopefully at scale for any sort of strategic insights that you can pull from it. So I imagine in the case of what you're doing, it must come as a relief to companies that are sort of beginning their data journey to not have to kind of worry about everything given the complexity of it. I mean, if you're managing kind of the pipeline aspect of it, then it sort of makes things simpler for them. For those companies that are newer in the space, they probably are hearing a lot about data quality, about cleaning up data sets, and before they can do an effective analysis. And I'm wondering kind of what defines data quality? You hear all these terms like this is good data versus, this is messy data or whatever. What does it actually mean to have good data quality?
Well, in the end, I think it means that you have consistency in your data, so that if two people are producing the same metric and consuming the same metric, hopefully it should be the same number, and ideally they're using the same source. I think it also means that it's providing insights and predictions and statistics that your company can rely on, that everybody has confidence in. In the end, it's measured by whether people trust the data that your data teams are producing. And that's a sort of like heuristic or sort of empirical definition of what data quality means. It means that people look at the data team within an organization and say, yeah, we trust the numbers that they give out. If occasionally it doesn't quite look right, we know they'll fix it and it'll remain fixed. I think earlier upstream, it means that you have teams that are coordinating the production of data, applying tests, having rigor around the way that the data pipelines are operationalized. It's all the mechanics of how you manage your data pipelines in a way that encourages collaboration, and participation, but does so in a way that has a close control of standards. That's why we think something like Airflow is really important, because it is, at this point, sort of the de facto standard for running data pipelines, and therefore represents sort of the most obvious way to create a single platform that everybody can contribute to. It's easy to use. It doesn't stop you from creating new data products, but it has sufficient controls and standards that you can enforce those levels of quality. But in a nutshell, it comes down to culture. Honestly, it comes down to culture.
Yeah, I was going to actually ask that because beyond the mechanics, it seems almost like in a certain way that trustworthiness of the data seems like almost like a soft skills problem for your data scientists or your data analysts, like kind of convincing the organization that this is indeed like, especially
Yeah,
given all the costs involved.
yeah. I mean, there are tools, of course, for managing data quality. There's a whole bunch of platforms and libraries and utilities that people have created. Great Expectations is one that comes to mind that's very widely used by data scientists, but there's a whole bunch of others. And in fact, Airflow and Astro has built integrations between Airflow and those libraries. But you're right; it is about a set of best practices. If you think about the world of typical software engineering application developers, I think it's sort of accepted, right, that you go through a QA process and you write unit tests and you have automation, you have your tests built into your CI/CD frameworks. I don't know if that's necessarily yet part of common practice for data engineers and data scientists. Obviously, should be. They are, in some sense, just another type of software engineer. They're creating technical products that are used as part of applications. So it's a combination of using those tools, but you're not going to use them unless it's part of that set of best practices and unless it's part of the culture.
It also seems that, I mean, given all the data that we look at Dice in terms of the incredible demand for data engineers and data analysts and data scientists and so on, means that, first and foremost, those sorts of specialists are premium. But second, it means that, and we also hear this from companies that we talk to, sort of if you have citizen developers, then it seems like there's also this interest in, I guess you would call them almost like citizen data analysts in a certain way, where you have new sets of tools coming up where people can self-serve their analysis to a certain extent.
Yeah.
And I'm also wondering kind of how that factors into it, because what you're describing is obviously and necessarily an incredibly sophisticated process involving highly trained people who are establishing all these parameters and these workflows to allow this to happen. But at the same time, you also seemingly have this company pressure to have people kind of doing their own ad hoc data analyses based off kind of whatever tools are available and pipelines and so on. Do you think, I mean, organizations in terms of like establishing data policies and so on, I mean, what's the best way to approach that? I mean, do you hire experts and then sort of let them get to things when they get to things? Do you rely
Hope
on
for the best.
self-serve, even though it's unreliable? I mean,
Yeah. Well, it's interesting, especially because there is an increase now in terms of um, creating greater access to data and even starting to use some of the methods of large language models and code generations, for example, to let people write natural language queries. That's a whole other topic we could discuss as well. But it does create a risk in some sense that those types of disciplines and cultures that we were just talking about are ignored in favor of just opening up access to everybody and making it as easy as possible. I think it's partly a question of defining requirements very carefully and making sure that you have sort of exit criteria for what your data sets look like, just as you have acceptance tests for any function within an application. There are ways, I think, of being able to use some of the more advanced methods, not only to generate queries and generate data sets, but also to test them, right? So you can, in a sense, have this sort of bootstrapping capability that you are generating the data sets and then you're using automated methods to provide the test. But there's no magic here. It's very important and has always been important in the practice of data analysis and data science to be able to establish upfront what you expect the results to be, bounds within which prediction should be operating, historical data sets that your models are tested against, ground truth numbers around dashboards and statistics that you're creating, and then encoding those in the pipelines that you're running. Again, there's no special magic. It's just a matter of doing the work and making sure that you have clear requirements, and then having pipelines that are not just generating data sets, but also running those tests. For us, I actually run the data science team at Astronomer, as well as sort of establishing our machine learning and AI strategy. And for us, it's very important to have a framework for submitting our pipelines that essentially forces you to create proper documentation, well-specified dependencies, and clear exit criteria. Otherwise, it just is madness.
Yeah, no, I'm sure it is. I mean, and then it ends up being a worse problem than it almost you're taking 5 steps back for every step you're trying to take forward. In
Yeah.
terms of, I've had a couple of conversations lately in terms of machine learning and AI, and in terms of establishing. In fact, I was having a conversation with the CIO of TIA CREF in an episode that's going to come on in a few weeks, where he was talking about establishing sort of these baseline protocols and these guardrails for the use of data in the context of your models and AI and ML. And I'm just curious about, since you're so immersed in data and data pipelines and everything like that, and that obviously ladders into all of that, how are you approaching AI and machine learning policy? Like, kind of what's your thinking on that on kind of like a top level? Because expecting everything to flow from there.
Um, at a high level, um, I think the way that we are handling AI is to say, proceed with caution, embrace the technology, but learn from others. Because it is so early right now that it's actually quite difficult to find what is the right way for generating new documents, or doing code generation, or creating a chatbot. Lots of people are talking about it, almost too many. So there's a bit of a cacophony in terms of what the right approach is. But nevertheless, there are emerging standards and templates. And I think we're going to see this increasingly happen in the next 12 months, I think, that rather than everybody building this from scratch, there'll be reference architectures and reference implementations that essentially create those guardrails or provide those guardrails for you. They say learn from others and the way that others have built these applications of AI and machine learning generally, rather than trying to reinvent the wheel. Um, but I think, again, it comes down to having careful testing, right? We have our own AI applications that we're building. And it's been very important for me to say, okay, before we even start this, before we get into the weeds of the technology, let's establish what is it we're expecting to see out of this in terms of the quality of the responses that the models are giving you. And having some degree of manual testing and a set of tests that you've created up front. That to me is like the most effective guardrail, which is to say we have established up front what we expect the output of the models to be. Of course, these are not entirely deterministic, so this is easier said than done. But we've established up front what we expect these to be, and we just continually run those tests and automate them as much as we possibly can.
Mm-hmm. It seems with, I mean, some companies obviously have a very clearly delineated set of goals when it comes to those kinds of programs, but then you occasionally meet these companies where they want to design a chatbot that sort of throws a wider net, and it seems like they're not quite clear on those goals of what they want the thing to do. And so it seems like that would be potentially difficult. I mean, the other thing too, it seemed, I don't know if this is sort of forefront at your mind, but sort of protecting data as well, and ensuring that it's not learning off something that shouldn't be learning off, and it shouldn't be outputting something it shouldn't be outputting. Is that a difficult problem? I just have no sense of how difficult that problem is in terms of securing and making sure that data
It
is
is.
sort
It is, in a sense, it's the problem of lineage.
of okay.
It's the problem of saying that this prediction by this model was produced by this version of the model that was trained on these data sets, ingesting these data sources, right? There's a long chain there of causality and lots of things that can go wrong and lots of versioning. This is exactly the sort of thing that data engineers and data scientists have been wrestling for a long time. And there are actually standards and platforms and sort of reference models for doing this. Astronomer itself and Airflow have adopted open lineage as a standard, which is a way of saying that this asset, whether that's a data set or model, was produced by these upstream assets and then keeping track of that over time. And that's not an easy thing to do, right? You have to sort of analyze queries, you have to provide mechanisms by which your developers can easily hook their data sets and their pipelines up into upstream pipelines and make sure that those are all coordinated. It's not an easy thing to do because you want to automate that as much as possible, because in the end, the engineering teams are going to be lazy about it. Yeah. But that, in my mind, is really the only way that you can really solve this problem, is by having this is going to sound self-serving, but it really is the only way. You have to have a central platform, no matter how meshy your organization is and how federalized you've created your data infrastructure. There still has to be a standard platform and a standard approach to developing your pipelines, which enforces things like the testing that we've just talked about and clear lineage. Now, the more that central platform can actually do the lineage for you, that's really the approach that we've taken by embedding that standard of open lineage into Airflow and making sure that our platform feeds it properly. Then the better off you are, because you don't have to rely on the teams doing it themselves. But again, there are best practices and standards around this. These open lineage as standards has been adopted by Microsoft and by Databricks and by Apple and by Astronomer, for that matter, and we're actively promoting that. So that it really becomes almost out of the box, almost automatic, that you're tracking the provenance of your predictions.
How long do you think, I mean, every technology goes through, I guess, for want of a better term, a Wild West period and a hype period and kind of all these things where people are trying to figure out, like, there's a battle for standards, there's a battle to kind of figure out best practices and so on. And I could be wrong, but I feel like we're in the midst of that right now. How long do you think it's going to be before AI and ML as an industry sort of asymptote and level off into something that's, I don't know, a little...
So it's such a great question. I mean, my optimistic side says it'll happen by next Tuesday, because things are moving so quickly in the world of AI and large language models and generative AI that it really does seem like, whereas yesterday we had no mechanisms for assessing the quality of a model, now there are 3 companies that are developing that as a specific service. Right. And there are methods out there. I haven't even mentioned this aspect, right, in terms of putting guardrails around things. But there are services that are beginning to come around that use the methods of generative AI themselves to actually assess the quality of output. So that's obviously very helpful. So the degree to which this is the Wild West seems to change every day. And as I said earlier, you are starting to see reference models come into place so that people can not have to reinvent the wheel. Having said that, right, in the end, large language models and generative AI are just other forms of machine learning. And I remember having conversations 10, even 15 years ago, when sort of data science was just becoming really popular as a discipline and as a hiring priority for organizations, saying, well, we're really in the early days of machine learning. There is no equivalent of agile in the world of machine learning, or if agile is the thing that should be adopted, it's not widely adopted. And I feel like every 2 or 3 years I have a conversation about it where it still seems like it's just as bad. It's still the case that while in the world of the software engineer, you have a lot of rigor, I think, around DevOps and around continuous integration, continuous development, and agile practices. Those just don't seem yet to have fully infiltrated the world of the data engineer and the data scientist. So maybe it's next Tuesday, maybe it's still a little ways away. On the other hand, I do think you're starting to see the rise of platforms for model ops. Things like weights and biases and open source platforms like MLOps. And then I think, again, it's been remarkable to me the degree to which Airflow, which really grew up as a data engineering platform, has just very naturally moved over to the world of the machine learning engineer as well, because it's similar, right? You're ultimately manipulating data to produce new assets in some sort of pipeline that you want to run operationally, usually on a schedule with dependencies handled. It's the same problem that you're trying to solve. So I think I'm going to end up a little bit more on the optimistic side, because it does seem like finally the world of the data scientist, machine learning engineer is converging around something that begins to look like agile best practices.
I mean, that definitely seems fair. I mean, so anyone who's listening to this who wants to break into the data science realm, I mean, in terms of the skills that they need to learn, obviously machine learning would be near the, I mean, things like CI/CD, obviously, and those kinds of best practices, but then also machine learning would be essential, would you say? I mean, like,
Absolutely, you can't get away without it. I mean, like I do a lot of mentoring at local colleges and just with friends, kids who are trying to get into the world of data science. And you need to learn Python. You need to learn at least the basics of statistics, and you need to take courses. Most of the ones that you'll see in undergraduate classes or master's programs are sufficient in machine learning, but there's lots of online classes as well that you can take. I also encourage people to learn SQL. It's the language that no college teaches, as far as I can tell.
really? Wow.
It's
So
amazing. I was at
very
Berkeley
ubiquitous.
recently, and I mean, Berkeley gave us Postgres, the greatest gift they could possibly have given the world of the developer, and they still don't teach people SQL. It's just completely crazy, and yet it ends up being so much of what you do, right? Python may be still the lingua franca of the data scientist, but you end up having to do a lot of querying as well against databases. So those are the things that I think you need to learn. But the bottom line is just getting your hands on some interesting data and doing something with it. Right? If you can do that through an internship, or you can do that through sort of full-time employment, then good for you. But just finding some data about something. A friend of mine who is a sports nut did some analysis with baseball statistics going back to the 19th century, and we gave him a job based on his analysis that he did. It was just so impressive. And I have friends who are really interested in music, and they analyze waveforms and analyze the structure of music, right? It's like, just get your hands on some data that you find interesting, think of an interesting question, and then see what you can do with analytics and machine learning.
The this is a side question, but for years, some of my colleagues were talking about how R was a language for data science, and that it had been swallowed, but mostly in an academic context, and then it had been swallowed by Python. But then you find people who are still like, oh, you should still learn R and so on. Should people learn R? I realize this is a side question. It's just something that keeps popping up again and again. I'm just
No,
curious your take on it.
it's an interesting question. I mean, I want to say yes, because R has given the world of the analyst so much, and there's been so much put into it, and I have a lot of affection for it, and also don't really like it that much. It's a little bit weird, but no, honestly, I hate to say it, but just learn Python.
Yeah. Yeah, no, that makes sense. I mean, it's amazing how Python, just the sheer ubiquity of Python is really stunning. I mean, in data science and kind of every single twist and permutation of all these different tech fields, and Python still remains the thing that everybody loves, or not loves, but work with.
Yeah, it's reasonably easy to work with. It's very well supported. It has integrations and libraries and modules for pretty much everything that you can want to do. To a certain extent, these things just take on a life of their own. It may not be optimal in any sense from the point of view of being a programming language, but once enough people get behind it and they create those libraries, the same thing happened with Java, right? It's like it gets popular enough that people just create a rich ecosystem around it, and Python is about as rich as they've ever been.
Yeah. So last question is, I mean, where is Astronomer going? I mean, now that you've built sort of this commonality, like this platform, I mean, I mean, and granted, you obviously can't talk about a roadmap too deeply, but I'm just curious about kind of where you're seeing it evolving, especially vis-a-vis the rest of the market right now, and how you're trying to be that provider.
Yeah, yeah. To a certain extent, we want to continue being the default cloud provider for all of your data pipelines. I like to think of us as sort of like the FedEx of the data supply chain, right? I mean, we have organizations like Walmart and FanDuel, a pretty wide range of companies who are using us to manage literally tens of thousands of pipelines, hundreds of teams, different data engineering teams, all trying to collaborate with each other, and just making sure that that's super reliable and super cost effective and easy for people to use by providing, not everybody wants to learn the in-depth nuances of Airflow, so providing different interfaces that everybody can take part in that still remains our bread and butter. But honestly, the world of AI machine learning is really key for us in our new roadmap, and I'm happy to talk about that. And in a sort of bi-directional way. First of all, we want to make sure that we take advantage ourselves of AI and machine learning. So there are ways that, for example, we can have users who are troubleshooting a broken pipeline or are seeing tasks finish later than usual. Can they leverage the methods of generative AI to be able to prompt them in the right direction for their troubleshooting and provide answers? I think that's almost becoming standard in a lot of enterprise platforms now, that a help menu doesn't cut it anymore. I want to be told where I should go to figure out the source of the solution to this problem. But even more advanced things within the product. I love the idea, for example, of automating the production of data dictionaries. I mean, Airflow pretty much knows everything about your data network. That's sort of by definition what it is. It is your data network. So can it learn from your code and from your pipelines? Can it learn from your code and pipelines what is the meaning of each field that you're producing and automatically create a data dictionary? That's sort of a pet project that we're working on. But then flipping that on its head, so that's using AI within Astro, our platform, but then also making sure that Astro itself is useful within AI, right? And again, as we found, starting out as a data engineering platform, it's now become really dominant as an operational ML platform. And we just want to make sure that that's been used by companies as diverse as Lyft and FanDuel, as I mentioned, to use Airflow as their platform for machine learning. We want to make sure that that is available to everybody just by really educating the world about how Airflow can be used to run all of their machine learning pipelines.
That's a wonderful goal. Cool. Well, thank you so much. This was a really fascinating discussion. I'm glad that we got to plunge deeply into the nuances of everything ML and AI related, especially the guardrail stuff. I mean, I get so many questions about policy, AI policy and guardrail policy and sort of first principles around that. This is really going to be useful for a lot of people to hear.
Yeah, you're starting to see, of course, some government sort of initiatives around quality and safety and ethical considerations in models. And although those haven't really hit most IT departments or data scientists yet, they're mostly targeted at sort of like the LLM providers and so on. They at least are starting to tell us that you have to make sure that you have visibility into the pipelines that feed these models, that you know where the data is coming from and where it's going to. And again, with our sort of central data platform, we think that that's sort of the core ingredient for being able to manage those safely. And I think whether those turn into regulations with teeth anytime soon, we all know that it's the right thing to do anyway. And so that's what we want to support.
And that's it, folks. If you're someone who works with data, and increasingly everyone's working with data, I hope you drew some key lessons from our discussion with Steven. Here are some quick takeaways from that discussion. First, it's important to define data quality. Is there consistency in your data sets? Is everyone comfortable with the sources, metrics, and outputs before you begin whatever project that really needs that data? Everyone in your organization should have confidence in your data and the insights you're producing from it. Fortunately, there's a variety of tools that allow you to manage and evaluate data quality. Second, when it comes to AI, it might be best to proceed with caution. Embrace the technology, sure, but also keep an eye on what others are doing. It's early days for AI, which means it's difficult for everyone to truly find the right way forward. Within a year or two, Steven thinks there will be reference architectures and implementations that will establish some guardrails for AI development. But until then, it's important to be as careful as possible as you implement and test your own AI-based solutions. Third, if you're interested in data science as a profession, you need to learn a core group of skills, including, but definitely not limited to, Python, which Steven calls the lingua franca of a data scientist, SQL, machine learning, and statistics. We covered a whole lot of other topics during the episode, of course, so give it a re-listen if there was something you missed. We'll see you next time, and remember, DICE is your best resource to find the tech talent you need to fill your open roles, and for technologists, the best place to grow your tech career.